So, continuing with our daily SAT practice, uh, again, I always recommend try the problems, pause the video, and then when you've come up with your solution or gotten as far as you can, then unpause and watch and listen to the solution or solutions that I have for them. So, give this problem a shot. Okay, so in this one, we want to know which of the following is the relationship between H and C. And what I see over here, I have this graph where I see a line. H is like my X value, C is like my Y value. So I'm going to treat this as most of us probably have. There's multiple ways to do this. Here's just one. But let me ignore the H and C and just go after this as X and Y to start off with, because that's probably best for us. And I notice right away I have a line, and I actually have all the information I need to get this into slope-intercept form. So Y equals mx plus b. Hopefully, this will lead me straight to the answer. So this b value, change colors on that, this b value is the y-intercept, which happens right here. So that's at positive 5. This m value, now this is a little bit trickier to see. This m value is the slope. So slope is rise over run. So you're like, okay, we go up 4 boxes, or sorry, up 3 boxes over 4 boxes. But that's not correct. I go up 3 units because I go from 5 up to 8. So this is a plus 3. But from here to here just goes from 0 to 1. So even though it's 4 boxes, it's only over positive 1 horizontal unit, which means my slope is just 3, and I get y equals 3x plus 5. Or, going back to the variables we actually have, where h is my x and c is my y, I should get c equals 3h plus 5. Now ideally I'll see that. Let's see. Yep, right here. If I didn't see that form, then I'd have to do some algebra to change this into the appropriate form. Now, another option, let's just say that that didn't make sense to you, or you weren't quite clear, or you had a ton of extra time. You could have actually checked points. So I see that I have this point 0, 5. I have this point 1, 8. I have this point 2, 11. So forth, so on. I have these nice integer points, and I can actually put them in and see which one works, where this is my H, this is my C, and I can check and see, okay, does 5 equal 5 times 0? And it sure doesn't. So I know that that's not the case. I can put this in here, and when I try, does 5, I guess you put a question mark, I'm not sure, does 5 equal 3/4 times 0 plus 5? And it does, but then when I check the next one, this one, does 8 equal 3/4 times 1 plus 5? This one does not work. So you can see I can eliminate those using that method. And notice this right here is what's called a distractor. This 3 over 4 is trying to see if you understood that this is up 3 over 1, even though there are 4 boxes, or didn't catch that. Give this problem a shot. Alright, so we have this graph of y equals f of x, and the complete graph of the function f is shown in the xy plane to the side. For what value of x is the value of f of x at its minimum? So I want to find, minimum means lowest, or more generally, so smallest f value, which is smallest y value. And so I just look at this, and if I talk about the lowest point, well, clearly that's right here at this point, -3, -2. If I'm talking about smallest y value, I have y is 2 here, y is 0, y is -2, and I notice that I never get a smaller value than -2. And so I want to find the x value that gives me this minimum. The x value is -3. Okay, give this problem a shot. All right, so we have a system of inequalities, and it says in the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between A and B must be true? All right, this is quite a problem. So let me set this up. We have an axis. We know that 0, 0 is in my solution. Now, let's look at this carefully. So I'm going to look at this line, y equals negative x plus a, first of all. So this would have a -1 slope and have a y-intercept at a. So if a is down here, I would have a line like this. If a is here, I'd have a line like this. If a is here, I have a line like this. I have all these possible parallel lines for what a could be. But here's the thing. I want to have what's less than this, which means I want to have things below. And so if I have solutions below, let me get rid of all these lines. If I have a down here, I'm only going to get, I know I'm making solid lines, it'll be dotted, I'll get there eventually. This is where my solution space is, and so 0, 0 would not be in there. So that's not doable. Basically, my A has to be somewhere up here. And so when I graph this, I will get something that looks like this. Dotted because we have a strict inequality, and I'll get the half plane over here. Noticing that 0, 0 is inside this half space. Okay, now similar things. This, if I just look at y equals x plus b, this has slope +1 and y-intercept b. And so those lines would look like this. There's an example if b is negative, if b is less negative, if b is positive. And I want to consider things above, greater than, this line, not actually on this line, but above this line. And I can see if my line is up here, 0, 0 will not be in that solution. So I need to have a b value down here. So let me get rid of those. And again, it's a strict inequality, so I'll make a dotted line. I can see that my b value is down here, and I'll get the half plane up here. And you can see that these inequalities split the plane into 4 regions, and the actual solution space will be this quarter over here, which includes 0, 0. Okay, now we need our inequalities. So what this basically says is, I know that A must be positive, I know that B must be negative, and now let's see what happens. So must be true. If A is positive and B is negative, does A have to be bigger than B? And yes, it does. Okay, so that must be true. If A is positive and B is negative, can B be bigger than A? No. In this case, so I'll give 2 examples. Let's consider the example A equals 2, B equals -1. In this case, the absolute value of 2 is bigger than the absolute value of -1. However, I could also have A equaling 1, B equaling -2, and in this case, 1 is not bigger than 2. So this one, it can be true, but does not need to be true. This is very sort of similar. I could have A equals 2, B equals -2, and yes, A does equal -B, and yes, these do satisfy the requirements over here. However, I could also have A equals 1, B equals -2, and in this case, this is not true. So this could be true, but does not need to be true. We need to know what must be true. All right, give this a shot. So a food truck sells salads for $6.50, each and drinks for $2 each. That's an expensive salad. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? So this is sort of a textbook system of equations problem. So let's use these variables. So let me define the variables. Let's see, we have salads and drinks. So I will have S be the number of salads sold, and D be the number of drinks sold. So now I just need to write the two equations. So on one side of things, I know that I have sold a total of 209 salads and drinks. So that means S plus D must equal 209. On another note, I know that I have made the food truck has made $836.50. So that means $6.50 for the salad, so 6.5 S plus $2 for the drinks, 2D, is equal to $836.50. Now, I'm going to finish this off. There's another way to do this, but let me finish this off first. So I'll go through and solve this system, and I'll solve it as I would do many. So I want to eliminate things, and I can see that if I multiply this by -2, the d's will cancel. So let me do that. Multiply that by -2, and that will give me -2s minus 2d equals, that's going to be -418. Again, this is a calculator test. Feel free to use the calculator if you need to. All right, this one I will leave unchanged, so I have 6.5 S plus 2D equals $836.50. The D's cancel. -2S plus 6.5S is 4.5S. And I'll go to the calculator for this, so let's see, I have $836.50, so 836.5 minus 418 gives me, oh, okay, that was almost half, 418.5. So, and now, to solve this, I'll divide both sides by 4.5, and do that in the calculator because I don't have a calculator in my head, so divide by 4.5, and I get 93. So the number of salads is 93. Let me check. I want to know how many salads were sold, so there's my answer. Now, there's another possibility. So this is how I would do it, but the other possibility in this case is probably not that much slower. So if I know that 209 total were sold, if S is 77, I can just subtract from here, and I would get that the drinks would be 209 minus 77, which is 132. And I could check that in this, see if it adds up to 836.50. It doesn't. If S is 93, I can just subtract that and get, let's see, D would be 216, not 216, sorry, I can't subtract, 116. And when I put this in, you'll see it works. So I can use the easier equation and these possible S values to get, I'll just show it. If I tried this one, so I got D by doing 209 minus 77, which gave me 132. And then I can check if it works here by seeing 6.5 times 77 plus 2 times 132 and see what that's equal to. So when I actually multiply that out, let's see, 6.5 times 77, 500.5, 2 times 132 would give me 264. And when I add these up, I actually get 764.5, which clearly isn't $836.50. Okay, give this a shot. Alright, so Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Okay, so we have, let's see, that's how much is paid. So we paid P. We had tax 8%, and let's say the original price is C, so C will be the original price. Now, there are a couple ways to do this. So I'll do this the more direct way first, but then I'll show you a way you can sort of cheat your way to the right answer. So in here, I can go through and say, okay, if I have a 20% discount, that means I'm only paying for 80% of the laptop. So I'll have 0.8 times the original cost. But after I do that, I add on an 8% sales tax. And adding on 8% means that I have 108% times the original. So I'll have 101.08 times 0.8 C. And when I do that, I'll go to my calculator and just do 1.08 times 0.8, and I'll get 0.864. So 0.864 C will equal P. Okay, now I can solve that by dividing both sides by 0.864, divided by 0.864, and so the cost in terms of P would be P over 0.864. Now, I don't see my answer here, but remember, I got 0.864 by multiplying these two numbers together, so this is P over 1.08 times 0.8. And let's see, I get my answer right here. Now, another possibility is this, and this isn't great, but it will work, and it'll work pretty much all the time for these multiple choice questions. If something works in one case, in every case, then it has to work for specific cases. So if I were to ignore this general case and say, okay, let's just say that it cost $100 to begin with. Well, if I have a 20% discount, so after the discount, it will be $80. And let's see, then I include 8% sales tax, which is going to be 1.08 times 80, and that would give me $86.40. And so I can actually go through and set this up. There's going to be the amount I paid the cashier, and then figure out the connection between these two numbers. So I can do that. It's not great for this case, and it's going to be kind of tricky, but that would work. Okay, we'll continue this tomorrow.